When you see an equal sign, it may mean many different things. So let me give you some examples. Say you have 3x plus 1 equals to 3x plus 3. Now, you may notice that all I did was I distributed the 3 to x and also 1, and then wrote this down. So I did not write a random equation. I actually wrote something that's true for all values of x. Whether x is 1 or 2 or 3, the left side evaluates the same value as the right side. So let me just give you an example. Let's say x is 3. 3 plus 1 gives you 4. 4 times 3 is 12, which is same as 3 times 3 plus 3. So they both give you 12, right? Whether x is 3 or 10 or 1100, whatever, the left and right are always equal because you're using the distributive property to set them equal. In this case, we say this is an identity because it's true for all x values. Okay. Now, however, if you had something like 5x plus 1 equals to 3x plus 3, then this is a different matter. Of course, this is not true for random x's no longer because 5x plus 5 should equal to this. It's not 3x plus 3. But we can consider this as an equation and solve for x. So let's do that. If I multiply them, it's 5x plus 5 equals to 3x plus 3. And then you subtract 3x both sides and subtract 5 both sides. What I'm really doing is I want to move this 3x to the left and 5 to the right. Now, why do I want to do that? Well, to understand what I'm doing, you need to have the concept of terms. What's a term? Term is something that's multiplied. So 5x is multiplied together. That's one term. 5 is a term because it's not multiplied to anything. It's just by itself. 3x is a term. 3 is a term. So you have 4 terms here. Over here, you have 5 times x plus 1. So that's one term. 3x and 3. So this equation has 3 terms. Now, once you have the concept of terms, then you can start trying to solve equations by moving around terms. You can solve equations by moving around terms. So here's a term, and because this term also has x's, and to solve for x, you want to put those x's to one side. So 3x goes here, and you can do that by subtracting 3x. Or in other words, if you move a term, then the sign becomes the negative of itself. So let's summarize this again. Whenever you move a term across the equal sign, it gains the negative sign. So if it's negative, it becomes positive. If it's positive, it becomes negative. Okay. So the result of this would be 5x minus 3x equals to 3 minus 5. 5x minus 3x, well, it's like you have 5 of these x's, 3 of the x's are taken away. How many x's do you have? So let's say you have a store and you have 5 Xboxes, and then you sold 3 Xboxes. How many do you have left? You have 2 Xboxes, right? Something like that, right? So that's equal to 2x. 3 minus 5 will be negative 2, and then finally you divide by 2, you get x equals to negative 1. Okay, so this one here is what we call a conditional, because it's true for x equals to negative 1 only. Okay, but the word conditional is not used that much. Often people just say, oh, this is an equation, whereas this is an identity. So this top one is an identity because it's always true. This is just a regular equation where it's true for some values of x. Okay. On the other hand, you can have something like x equals to x plus 1, which is never true, right? Because, look, x plus 1 is always greater than x, because anything plus 1 is greater than itself. So there's no way x plus 1 can be equal to x, right? So in this case, if it's never true, it's called a contradiction, because it's never true. Now, when you have a contradiction, one thing that you should know is that if you subtract x both sides, you get 0 equal to 0 plus 1. So you get 0 equal to 1. So you get, when you have a contradiction and you simplify, you end up with something that makes no sense at all. 0 is not the same as 1, and it's written that way, right? So that's why it's a contradiction. Yeah. Yeah. Bunch of exclamation marks there. Okay, hopefully you now understood the meaning behind identity and contradiction and just a regular equation. Now let's move on to an example of an equation. Here we have another equation that has 4 terms, but the problem here is that this is equation with a bunch of fractions, and I don't like fractions. Nobody likes fractions. And the part that we don't like about fractions is that it has denominators, because if you didn't have denominators, it would be just natural numbers, integers, right? But with these denominators, it becomes ugly. Thankfully, whenever you're solving an equation, you can always get rid of these denominators by multiplying a single number. So think of it this way. 4 and 8 has a common multiple 8, right? Because 4 times 2 is 8, and 8 times 1 is 8, right? And then with this 8 and 3, what's the common multiple of 8 and 3? 8 and 3 does not share any common factor. In that case, you just simply multiply them together. So 24 is a common multiple of 4, 8, 3. Okay, so what I want to say is that 24 is the least common multiple of 4, 8, and 3. Saying that this number is a multiple of something means that if you divide by these numbers, you get a whole number. So 24 divided by 4 will give you 6. 24 divided by 8 gives you 3, and 24 divided by 3 gives you 8. So another way to say this is 24 is the smallest number which is divisible by all these numbers and gives you these whole numbers. Now, if you try to get something smaller, you'll quickly find that it's not possible, because, like, say if it's 12 divided by 4 is 3, that's okay, but 12 is not divisible by 8. 12 over 8 is like 3 over 2, so it doesn't work. Alright, so 24 seems to be the least common multiple. Once you have figured that out, what you want to do is you want to multiply 24 both sides. And these annoying denominators will be all cancelled. They're going to go away. Right, so let's multiply them, and here we have 24 times 3 over 4x minus 24 times 9 over 8 equals to 24 times 2x plus 24 times 2 over 3. Okay, now how do you multiply 24 times 3 over 4? You were told that when you multiply an integer to a fraction, this only gets multiplied to the top, right? So 24 times 3 is 72, and then you can divide by 4. However, because we chose 24 wisely, and we know it's divisible by these numbers, the better way to do it would be first divide 24 divided by 4 would be 6, right? So you have 6 times 3, which gives you 18. Same thing here, 24 divided by 8 would be 3. 3 times 9 is 27. 24 times 2 would be 48. And 24 divided by 3 is 8. 8 times 2 is 16. So use these numbers, and now you have an equation that's a lot easier to handle than before because all the denominators are gone. Okay. All right. Now let's use that same trick again. I'll move this term to the right and this term to the left. Remember, the sign has to change. Plus 16 now becomes negative 16. Negative 27 minus 16 equals to 48x minus 18. This would be negative 43. This would be 30. And then dividing by 30 both sides will give you x equals to negative 43 over 30. Okay, so that's the answer. All right, so hopefully you now see how much easier it is to solve this type of equation by first getting rid of the denominator, because once you do that, then calculation afterwards becomes a lot easier. If you don't do that, then you have to move this and you have to add, subtract fractions. Sure, that's a possibility, but it's a lot more work. All right, then we also need to know how to solve word problems. But it's really the word problem that's the most tricky part. I think a lot of you will have trouble with the word problems. Let's do a few, and let's see if we can manage to learn from these examples, okay? All right, so here's Jeff. Jeff works with bicycles. He has some child and adult bicycles. The number of adult bicycles is 9 less than 3 times the number of child bicycles. There are 42 adult bicycles. How many children's bicycles are there? Okay, those who have anxiety over word problems will think, I'm not going to be able to solve this, right? However, you have to think, and I think a lot of people have the wrong idea of what's thinking. They think trying to remember what they learned is thinking, but that's not thinking. Thinking is like figuring things out. Thinking is like looking at a part of it to see if there's something you can figure it out by doing some tasks that are similar. Okay, and that's the thing. A lot of times when you were learning math, you're told to just follow these steps and you're good. Okay. But when it comes to word problems, there are just simply too many examples that it's impossible to have a single step-by-step solution. There's no algorithm for it. You just have to think. And to think, it's to figure out things. And if you look at this carefully, there are 42 adult bicycles, so this is 42. And I think the most confusing part is right here. See if you agree with me. 9 less than 3 times the number of child bicycles. Okay. Now this is some serious sentence. It's not so easy to digest. So you want to first digest this, and then once you have a better understanding of this, then you want to look at how things work out in the rest of them. Right, now think about this. If it's 9 less than 3 times the number of child bicycles, and if you have trouble understanding what this is, then what you should do is first think about a problem just paying attention to this part. Okay, don't worry about the other parts. Once you have the understanding, you can do it. Okay, so let's just say the number of child bicycles is 10. So here's a question you can ask. Question: if number of child bicycles is 10, then how many adult bicycles? Well, let's see. If you have 10 bicycles, 3 times the number of 10, that's 30. So times 3, that's 30. And then it's 9 less. So what's 9 less 30? That means it's less than 30 by 9. So 30 minus 9. which is 21. So the adult bicycles is 21, right? Now once you do this example, then you feel a lot better about this cryptic message, okay? And if you still can't figure out, then try another number. So let's say the number of child C is like 20. In that case, what do we have? 20 times 3 is 60, and then you subtract 9 because it's 9 less, that's 51, right? Okay. And so you have the following knowledge. If there were 20 child bicycles, then there would be 51 adult bicycles. If there were 10, then there would be 21. And that's already a pretty good achievement because, see, we're looking for adult bicycles to be 42, right? So it seems like if the number of child bicycles should be somewhere between 10 and 20, because if it's 10, then you have 30 adult bicycles. When you have child bicycles 20, then if 51, that's over 42. This is under 42, right? So you can kind of have an idea that the answer should be somewhere between 10 to 20. And this is pretty important because later on, when you actually write an equation to solve it, you want to check whether this is correct or not. If it's not correct, then you have made some mistake somewhere, okay? All right, so hopefully now you have a better understanding of this 9 less than 3 times the number of child bicycles. Now, because it's asking for how many children's bicycles, we can put this as x. Once you have that as x, we can now write an equation for x, because if the number of child bicycle was x, how did we arrive at the adult bicycle? We first multiplied by 3, right? That's what we did, right? We multiplied by 3 to get some number. And then after that, when we get that number, we subtracted 9. And we said, whatever this was, that's the adult bicycle, right? But what is the number of adult bicycles? Is 42, right? So you add 9 both sides, and you have 51, and then you divide by 3, and that gives you 17. So the answer is there are 17 adult bicycles. Oh, I've been spelling wrong. B-I-C. Yeah. Okay. B-I-C right here. Okay. So adult bicycles. Okay. Alright, so hopefully that was a good motivation for you, thinking that it's like word problems are not too bad if you can come up with your simpler question and you can answer them. Alright, here's the next question. Erica earned a total of $50,450 last year from her 2 jobs. The amount she earned from her job at the store was $1,250 more than 4 times the amount she earned from her job at the college. How much did she earn from her job at the college? Okay, so because it's asking for how much did she earn from her job at the college, this amount that she earned from college, we're going to put that as x. And we can see that that x appears here too. Right? This is x. And then the sentence that you see, 1250 more than 4 times x, you don't think about this, it's just 12 more than 4 times x. That seems to be very similar to what we did before. So rather than trying to come up with an example, we can actually, hopefully you can just write down the equation for this part, which is 1250 plus 4 times x. Okay. So what is that equal to? That's equal to the amount she earned from her job at the store. That's another income. Now, is this value given? Well, no, it's not given. That's the problem. Erica earned a total of $50,450 last year for her 2 jobs. So apparently, whatever she earned here, this plus x is equal to $50,450. Now, there are two ways to approach this. One way to solve this would be to say, well, if the sum of this amount and that amount is 50,450, then this amount itself will be 50,450 minus x, if you think about it, right? And since now you have an equation you can solve. So that's what the question, if you see any question like this is what the question intended you to do, because then it's just an equation for a single variable. However, often, despite the fact that the system of linear equations will appear later, it's actually a lot easier to just use system of equations. So let's do the following. I'm going to call the amount she earned from the other job as y. So since 1250 plus 4x is same as this amount, we're going to say it's y. But then we also know that if you add x plus y, if you have x and then you add y to it, you get the total amount, which is 50,450, right? 50,450. Okay. So that's a system. Okay. And this is a lot easier to write down. And the solving this system is not that hard either. You solve for one variable and plug into the other. Thankfully, this is already solved for y, right? So I can plug that into here, replace y by this, and say it's x plus 1250 plus 4x. When you replace, put a parenthesis. Here it's okay, but sometimes it might have a minus or something multiplied. Parenthesis is crucial. That's equal to 50,450. And if you get rid of the parenthesis, 4x plus 5x, 4x plus x is 5x. And then you can subtract 4,450 minus 1250. So I took this term and moved it to the other side, which now says it's 49,200 divided by 5, and then finally x is 49200 over 5. Let's see, 9 times 5 is 45, 42, 9 times, oh sorry, 9 times 5 is 45, 42 is left, 42 divided by 5, that's 8, and then 20 divided by 5 would be 4. Okay, so the answer is that she earned in college $9,840. That's the answer. Okay, this is the last set of word problems I'm going to solve. Here, the sum of three consecutive even number integer is negative 312. Find the integers. Again, there is this three consecutive even integer. What does this mean? That's a part that requires some digestion before you try to tackle the entire question. So you start out by thinking of three consecutive even integers. Well, three even integers. You can have like 4, 6, 8. You can also have like 10, 12, 14. And consecutive means it's like the ones that appear right afterwards. So it's 10, 12, and then it has to be 14. You can't say 10, 12, 16 because then you'll be skipping 14. Okay, it has to be always first number, and then the next even number, and then the next even number. So think about these examples. Then, since we have to find the integers, we now have to come up with the means to express all of them. How do you do that? Well, let's just call x as the very first of the integers. Then what's the next even number? Well, we see that in both cases it's always 2 apart, right? Even numbers are 2 apart. If you have consecutive even number, they're 2 apart, so the next number will be x plus 2. And the number after that, the even number after that will be x plus 4. Okay, so now we've understood what this means. It's all one by one. Don't expect to be able to solve a word problem just right away. Requires thinking. Thinking means taking some parts of it and then think of examples, and from those examples you come up with, you learn something and you write. Okay. I mean, often in arithmetics, you have a question, and most of the questions it's solved right away, right? But once you're in algebra, you're often expected to work. Some questions it's easy, you can just find the answer right away, but questions like this requires thinking, and really it's the reason why you learn math. You're being tested on math, you're required to do math because math requires thinking. Okay? Alright, so you have to be more specific, it's a special type of thinking which we call analytical thinking. Analytical thinking means you take some parts of it, understand them, and then put them together. Okay, and that's an important thinking skill that gets used in many other classes that you take in college. Okay, all right. So what's the sum of these? Well, sum means you add them up, right? So you have x plus 2 plus x plus 4, and that has to equal to negative 312. Okay. Now what's x plus x plus x? That's 3x. 2 plus 4 is 6. Subtract 6 both sides, and you get 3x equals to negative 318. And then divide by 3, and you get x equals to negative 3 divided by 3 is 1. 18 divided by 3 is 6. 106. So that's the very first number. So what are the three numbers then? Answer is negative 106, and then the next number is plus 2, right? So add 2, that's negative 104. And negative 102 if you add 2 again. Okay, so hopefully it's impossible for me to teach you all the word problems. The skill that you really need to learn is analytical thinking. Hopefully you're inspired and you can try other questions on your own.